Hello, everybody. How are you doing tonight? We are here with some Kerbal space program for y'all. Let's make sure the stream is functioning somewhat normally. Says the stream is working. 60 frames a second. 6,000 kilobytes a second. Alright, looks like that is everything. So, I think the last time we were playing we had just failed to put a satellite in a polar orbit of the Mun, and we had also failed to, air quotes, explore the Mun because, of course, we did not bring back the vessel which went to the surface of the Mun. We brought back a vessel that had rendezvoused with a vessel that went to the surface of the Mun, which feels like a contract oversight, but I guess there's nothing we can do about that. So we have a new mission to build that has to put our satellite into the desired orbit. So let's see. We've got Jamie, welcome. Ian, Guerrero, JR, Caleb, Nathan. Nice to see you again, Nathan. Lucas, Rust code. Ooh, I don't know why I'd be putting Rust on a microcontroller. That sounds like not fun. That actually sounds like expressly not fun. Let's see. So we've got the Munner Explorer 4, I think was the most recent rocket we used. Maybe. Let's see. Does this one have our satellite on the side of it? No. Okay. So this one, not it. Let's see. So maybe it was... It wouldn't be the Hermes, would it? I don't think so. It might be Artemis. Is it Artemis? Welcome, programming nerd. This feels like it might be the rocket we're thinking about. But we need to change the design because clearly this is not good enough. So as cool as this looks, a nice... This is like a Saturn-Soyuz amalgam. It's got the Soyuz, and then it's got the Saturn-style lander. We need to do this differently. So we're going to lose the LEM. Yeah, there we go. And we're going to add landing legs to the CSM. Landing legs, landing legs, landing legs, landing legs, landing legs. Ground. Here we go. Nano, landing strut, micro struts. All right, we're going to go with these, I think. That's, like, not at all low enough. Okay, so let's get a bunch of these on. 4? We'll do 4. And then we have to do this little thing to get them low enough. Oh, and we're going to have to go, like, around so that they miss the satellite. Because this is a deployable satellite right here. Okay. There we go. That, like, sort of counts as... so let's see. Start retracted. There we go. Okay. So now we've got our satellite, our landing legs, and we're just going to try this contraption. Nope. Build fairing. That's what I wanted. Yeah, we're going to try this contraption. Oh, it's not letting me, probably because of the struts, but it looks like I got it. So we'll do that, and then we'll do that. There we go. That closes all of that off. We've got parachutes, but we have the parachutes covering the door, which we need to fix. So one parachute there, one parachute there, And 1 parachute there. Okay. Blackout, what is my history with the Cosmosphere? Well, Blackout, I was a camper at the Cosmosphere starting from the year I was in 2nd grade, which was like a long time ago. And in 2011, I started my Eagle Scout project at the Cosmosphere. That was 9 years ago. Wow, that's crazy. And then after I finished my Eagle Scout project at the Cosmosphere, I actually got hired as a camp counselor, despite the fact that I was still going to camp, which was kind of an interesting thing. I took a week off from work every summer to go to camp for myself, and my boss, who ran the camps, when I was on camp, he'd be like, "All right, Charlie, get me a count," and I'm like, "I'm a camper this week," and he's like, "Get me a count anyway." So Glenn was a great guy. So yeah, and then when I went off to college, I just always had fond memories of the Cosmosphere, and I'm definitely consider myself indebted to them for all they did to inspire my love of space. Common Centaur, welcome. Let's see. Okay, Lucas, why not put a fairing around the whole craft? Because I don't need the weight of a fairing around the whole craft, and plus it would make it hard to work. Let's start from the ground up. Boosters light. Then those boosters fall off. Then those boosters fall off. Then those boosters fall off. Then we stage out this middle stage. Then we don't really have a TLI stage. So let's see if we do vacuum delta V. We have this engine there. So that fairing comes off, that fires, and then this goes. Oh, it's got 3,000 meters a second delta V. Okay, so we've got 500. All right, so we've got like plenty. We've got plenty. That's what the answer is going to be. Okay. Sleep Dog, welcome to the stream. Oh, Blackout. I didn't know you worked in Wichita's such a cool place. I wish it had worked out better for the aviation industry there. But yeah, the Cosmosphere does have quite a collection, and I wish you could see the rest of it. Most of it is actually not on display. It's on this warehouse facility, and it's like something out of Indiana Jones. We have a bunch of like fighter jets just parked in rows in a warehouse at an undisclosed location in Hutchinson that is where our collection is kept, and it's a really cool place. We've got a bunch of spare spacesuits on storage, all kinds of cool stuff. I wish we could display more of it. Okay, so let's see. We've got, I think, everything we need here, which means that it's about time to go push this thing into space. Landing with this might be a little optimistic. But if I add more weight, it's gonna, if I remember correctly, I think it is, it's this stage that has the garbage TWR. This stage, maybe? TWR 1.4. Okay, maybe it got better since we removed the LEM. So let's check the contract requirements real quick. Rendezvous 2 vessels in orbit of the Mun. So we've got 1 vessel and this vessel. Return to Kerbal from the surface of the Mun. We'll be doing that with this. Build a new uncrewed probe that has an antenna and can generate power. That's this one right here. This is, so for those of you who aren't in, for you who might be in school, or maybe you're a low-level engineer somewhere, always read the contract. Read the contract, because sometimes you'll like find a gotcha here, like have a mystery goo unit on the satellite. Looks like I've got a mystery goo unit on the satellite, but if I didn't have a mystery goo unit on the satellite, I could go put this in orbit around the Mun and just like wouldn't get any credit for it. But with that, I'm going to stop my yapping and we're going to start the flying. So Science Marshall asks, oh, Nathan Marshall. Nathan, like from Meadow Lake, Nathan? Oh, that's so crazy. If that's really you, wow. That's so cool. Yeah, I love my job. I get to do all kinds of cool stuff I probably can't talk about yet. If you watched my talk with Jim Bridenstine, there's this like awkward moment where I like recognize something, then I can't talk about it. We were allowed to post pictures of it, but I can't like say anything about like who or what the program was for. And so yeah, so I love what I do. I get to do all kinds of exciting stuff on a day-to-day basis, and I'm really enjoying it. I'm really liking it here in Colorado. The transition from college has been a little rough. I was definitely a night owl kind of guy in college. I'd like wake up around like 10 and then, work till the wee hours of the morning making sure stuff got done. And now, we have our first leadership meeting at 7 a.m., which means I've got to be up before that. So it's just a whole thing. Um, cool. All right. Uh, Lakshim wants to know about an MBA at MIT. The Sloan Business School at MIT is one of the best business schools I'm aware of anywhere. So definitely a good idea if you have the opportunity. Um, wow. Welcome to the stream, Nathan. So Nathan is a super cool guy I know from back at the Cosmosphere actually, and growing up in the town I grew up in, and wow, that's crazy the people you see around the internet. How about that? Nice to see you, Nathan. I hope things are going well for you. Hopefully life is treating you well where you are now, and we should catch up sometime. Okay, let's see. I think that's the throttle, that's the guidance, we've got the Kerbonauts. All right, well, let's send it. Oh, wow, that needs some struts. That feels unhappy. We're gonna... I don't know, we want to keep the throttle up before booster burnout, so we burn off as much propellant as possible. Oh, wow, this is just not even sort of... Roll control, ladies and gentlemen. This does not have it. That's booster burnout and jet. Okay, so we kept everything that time. And our TWR is still 1.5, so we're still good. We're going to go supersonic. We are pitching over just a little too fast. Okay. 400 meters a second, 9,000 feet, so we're going to throttle down a little bit. Lose the boosters. Oh, that hurt. Apparently we're still flying straight. That's not great, but I think we can limp to orbit. It does this every time. I don't know how to make it not do that. I mean, I can add like the little retro rockets to pull the boosters away, but I don't know why. I wonder if I've accidentally clipped a booster into this. It's because it's always this one right here that's in line, 270 degrees off the hatch. Hey, Jamie. Okay, so that's booster burnout and jettison them. Let's check our apogee. Apoapsis, 41 kilometers. So we've got a ways to go still on that. We've got 1,600 meters a second, so we'll make it to orbit, no problem. We'll do most of our translunar injection burn with this core stage here. While we're at it, I think we can lose the escape system. Or I thought we could. Do I have maneuver nodes set up? Oh, I guess I killed the maneuver node by accident when I was messing around with it. That's unfortunate. Need to go up a little faster. Our apoapsis is kind of bottoming out. So we're going to go ahead and edit our maneuver node real quick. Edit action groups. Action group 4. That. Oh, it pauses the game when you do that. How convenient. Oh. Okay, it's not going to let me edit everything I want to edit. Never mind. That's why I don't have action groups set up. All right, 75 kilometer apogee. Let's activate engine. And then let's decouple node. And then we will get this thing pointed back prograde and wait for the space music to start. Oh, wow, Nathan, that's so cool. I have another friend who's working at Garmin this summer as well. But prototyping is always the fun stuff. Jamie wants to know what the highest altitude one of my rockets has gotten to in real life. Well, depending on how you define one of my rockets, I've sent, 3 flights to the space station, so 400 kilometers. But if you're asking about the rockets that I've built, just kind of personally by myself, I think the highest altitude that I have gotten one back successfully from is 41,000 feet. I've had a couple of flight attempts up to 90,000 feet, but all of them have shredded at Mach 3. Programming nerd. My preferred gravity turn profile is I go 90 degrees right away. That's my pitch kick. And then I do, at 5,000 meters, I do 70 degrees. At 20,000 meters, I do 45 degrees. And then I just kind of pitch over, depending on that. But as a general rule of thumb, the higher your thrust-to-weight ratio, the faster you want to be pitching over. It increases your efficiency. Chazzy, welcome to the stream. Did I give up on the compressor? No, not only did I not give up on the compressor, I've got it working. In fact, I've got a stream, I think, where I finish it, but I don't think I show it testing it on the stream. But I've actually, my next video for liquid rocket engines is going to be a solenoids video. And then actually my very next video is going to be my RCS system, which I finally got working with the high-pressure air system that I had laying around. So I have a 2-axis reaction control system. Maybe I'll bring it onto the stream later. I've been editing that video, actually. A really weird glitch happened where my audio recorded at a different speed than my my footage, so I have to resync everything, and it's a total pain in the butt. Okay, so we're gonna not forget to fly the rocket here. Last stream, I was just horrible at flying. I must have been distracted or something. I messed up so many times, and usually I'm pretty good at this game. But okay, so we want to get the periapsis up to 75 kilometers. So we'll just deal with that real quick. 82. There we go. We're in orbit. All right. That at least stabilizes us so we can do some of this without being so much time pressure. So let's save real quick and get rid of this fairing. Nice. Okay. That was kind of clippy, but okay. Sure. Whatever. We can do that. All right. Lakshmi wants to know how nuclear energy can be used to accelerate rockets. And the answer is you can use nuclear energy in place of chemical energy, but you still have to have reaction mass, either water or hydrogen or some other thing you can expel out of your rocket at high speeds to provide the reaction force necessary to accelerate your rocket. There's a couple of ways to do this. I think the best way right now is probably nuclear electric propulsion, where you use a nuclear reactor to run an ion engine. But there's a lot of people that are very excited about bringing back nuclear thermal rockets like NERVA. I don't like that idea nearly as much as some people do. I think nuclear kind of missed its heyday, but nuclear electric is still a great idea. Jamie, what do I use as a binder for the cherry limeade mix for the SRBs? I use hydroxyl-terminated polybutadiene. I buy it from RCS, Rocket Components Store, run by Rosenfield Consulting. They're the same people that do Aerotech motors, so they're really good chemicals. Caleb, would I make an attempt to fly a rocket to space if my liquid rocket engine produces sufficient thrust? I would love to fly a rocket to space, Caleb. In fact, I think I'm probably closer to doing it with a solid rocket motor than with a liquid rocket engine. The liquid rocket engine is probably years away from ever being on a rocket. It's got a long way to go. And it's also fancier than it needs to be for a space shot. Like, the liquid rocket engine is, like, closer to what you'd expect a small launch startup to be doing than, like, what you need just to launch a rocket to orbit. Oh, wow, I forget how pretty this game is. Look at how pretty this is, guys. This is, like, look at the detail in the clouds, and there's the light reflecting off the water, and the Terminator, and just the corona. This is so pretty. Okay, how many months do I think I am from a liquid engine test? Sleeve, if I am measuring the answer in months, I am a lucky person. Unfortunately, the coronavirus has shut down the makerspace I was doing all of my machining at, and this has been really a big problem. If I just wanted to, like, pay money, I could probably order most of the parts off the internet and have them custom machined for me, but that's not much fun to do, and that's not much fun for you guys, and also it'd be a lot of money. So probably, like, the answer to how long this engine takes to fire is somewhat dependent on how long till I get back in a machine shop. Real Life in Games, welcome to the stream. Common Centaur, I'm curious what you think of the new name in the launch industry, Astra. I actually can't talk about that. I have NDAs to worry about, unfortunately. But I can say judiciously that I was uh, visiting Alaska in February, and if you know many things about Astra, you can construe maybe why I might have been doing that. And actually, I knew about Astra back when they were in stealth mode still. They sent recruiters to MIT to try and pick people up, and um, I wasn't like super excited about the idea of living on a deserted island off the coast of Alaska or in San Francisco, but they have a really their founding team was pretty cool. I've heard some interesting things since then, but who knows? We'll just have to see how they do. They supposedly have another flight coming up here between August 2nd and August 7th. All right, so now we need to plan our trans-lunar injections. So if this is the moon here, we need to do our burn here-ish. Okay, a little bit more than that. And that's pretty good. All right, so we're gonna hit that maneuver node right there. Let's see. We're spinning a little bit, but I think we'll get to the maneuver node eventually. We've got 13 minutes to get the spacecraft turned around. Okay. How hyped am I for Perseverance? Like hype level, like this is like maximum hype. Hype level is like I'm gonna have to stand up. Very hype. Hype level very high. I remember when Curiosity landed, my parents told me to go to sleep, but instead I purloined their iPad and watched it under the covers while we were on a family vacation to New York City. And I was very tired the next morning and very, very glad I'd stayed up watching it. And my only regret was that I could not scream at the top of my lungs when it stuck the landing. I'd actually I gotten to hear Adam Steltzner give a talk right before that, so I was very excited for it. He's the guy in the video, the really excellent entry video about Curiosity. Oh, what's it called? 6 Minutes of Terror or something like that. Okay, what do I use for a flight controller? Jamie, the RCS system is designed to fly using Ava, but when I fly my rockets normally, I use either a Telemetrum or a Telemega, typically. Okay. Yeah, so I talk about some of the experiences I've had in the space industry on stream. I recognize a few new names here, so I play Kerbal Space Program and I talk about things that I've built rockets for. But yeah, no, definitely I had some really cool opportunities, and whatever I can share, I'm happy to do so. Unfortunately, like I said, particularly things around SpaceX, I'm under NDA for still. So, what's my current favorite variant of Atlas V? So I like the 411 just because of like how kind of nuts it is. I really like the 4-meter fairing Atlases. I wish they'd done like a 451. That would be a great configuration for interplanetary missions. Unfortunately, the Centaur is just not up for it. But that'd be a fun one. I also kind of wish they built Atlas Heavy. I mean, Atlas has really gotten a lot more competitive since SpaceX started flying, but yeah. It's I'm excited to see Vulcan fly. Hopefully they're able to execute on Vulcan really well. Am I more excited for the rover or the drone? The rover's gonna last longer, but I'm really excited that we're finally flying things. To be honest, when they first announced Ingenuity, I'm like, they were talking about we're gonna do this helicopter to Mars. I'm like, there's no way NASA signs off on that. I'm like, NASA's way too risk averse to ever prove anything like that, let alone as like quick and dirty as they did it. Like they used all this off the shelf hardware, like Ingenuity, as far as I could tell, was like somebody was like, it would be really cool if we did this, and they like put nights and weekends into it until NASA picked it up as a real program. And I still can't believe it actually got picked up as a program. I'm really excited about it. Ismail, have I worked with Kevlar for nose cones and fins? Kevlar works. Given the choice between Kevlar and carbon fiber, go with the carbon fiber. Kevlar is a little better than fiberglass, but really I only use Kevlar in my shot cords, not really in the composite structures. Lakshmi wants to know if there are any possible flyby missions soon. I've seen a few ideas for like wafer sats powered via laser towards Alpha Centauri, but even that would take, half a century or something to get to Alpha Centauri, or 100 years or something. So probably not unless there's like a major breakthrough in technology soon. Welcome, Iblis. Welcome to the stream. Ian, Ava is completely public, and RCS is, not a secret project. It's just a project I'm working on for the heck of it. So no leaks. Common Centaur, if I could work in the space industry at any location at any time in the past, where would I go back to? I don't know. I would like to have started my career at 2008 SpaceX. That would have been fun. But no, I'm very happy with where things are now. I don't have any like particularly large amounts of nostalgia. I think it's a great time to be in the industry, and you can have like a big impact now compared to where you were in the past because the teams are smaller and more nimble. Blue tube for airframes versus carbon fiber. Why is this a question? Use the carbon. The carbon is amazing. Why would you use blue tube? I haven't built a non-composite airframe rocket in a long time. Actually, I've got several rocket parts within arm's reach of me right now. Sleep Dog, welcome to the stream. Real life and games, I use composite rocket fuels, so APCPs, essentially the same stuff NASA uses in their solid rocket boosters. It turns out to be much higher performance than like those knockoff sugar motors you see all around the internet. And so if you do like the dollars per Newton second of impulse, it comes out to be pretty favorable. Also, it's a lot safer, and it's more fun to make. It's like when you're making APCP, you feel like a rocket scientist, and when you make sugar propellants, I've done hundreds of sugar motors before, and mostly you just feel like you're about to lose a finger. Jamie, what are my opinion on flat earthers? Well, conspiracy theories, I think, probably denote people who have been lost by the scientific community. People who either exhibit gullibility or it makes them feel empowered to have this secret knowledge that is denied to people at large. It's like a community. I don't think they're rejecting, round Earth because they like truly believe that the Earth is flat. I think they're rejecting. I think they believe in flat Earth because that belief grants them access to a social group in which they have status, and is a social group that allows them to feel empowered over the sheeple, if you will, that don't belong to their social group. So I think it's actually a failure of social dynamics, and rather than a failure of education primarily. Azure White, what's your funniest story with liquid rocket engines? I don't know if I have a lot of funny stories. I have a lot of stories that I would probably get in trouble if I told. I remember the very first liquid rocket engine I built. I was doing it with a friend at MIT, and we did it to win a bet. We'd bet some other group that we could build a liquid rocket engine in one summer. So we put together this like 7-pound thrust rocket engine that like was really derpy. It used GOX and ethanol, and it was controlled by hand. There were no electronics, so all the valves were hand operated. And it was inside of this big polycarbonate box in case it blew up. And we ran it for the first and only time the night before the bet was over. And the losers of the bet had to sing "I'm a Little Teapot" in front of the whole class at college. And so we really wanted to win this bet. And we got to class the next day, and we showed our video of this rocket engine testing, and the people were like, "Oh, we weren't serious about that bet. We were just joking." And we'd spent like $2,000 building this rocket engine. So that was kind of funny. The real funny part of that story is the parts I can't tell, which is exactly how bad of an idea it was to test that thing. It was probably eminently hazardous to health of all people near it, but I learned. I got better. My eyebrows grew back, and it's still in one piece. It never threw shrapnel everywhere. Okay. Jamie Cole, can you start a series after the liquid rocket engine one has finished where I build a rocket? The liquid rocket engine series is never going to finish. I'm just going to keep working on it till it, I'll tweak one thing, add another thing. When one rocket engine is done, I'll build a bigger one, and it'll just be liquid rocket engine, episode like 143 or something. I don't know. I'm just talking about liquid rocket engines in the series. Let's see. I'm trying to... Okay. Check your local laws before building rocket motors. Yes, please. Thank you for the safety warning. Always follow all applicable local regulations when building rocket motors. All right, we're going to light this motor now, and then we'll have to stage off in the middle here. And then drop this stage. Decouple. There we go. 400 meters a second left. All right. Lakshima wants to know if I'll be the CTO if you have a space venture. Maybe. You'd have to give me your pitch. You know, it might just be that I'm CEO and you could be CTO. Who knows? Let's see. I will get to the pumps thing in just a second, because I have a really good spoiler for that. $30, $20, $10, and shut down. Okay. So I'm going to go get something to show on stream real quick about the topic of pumps. Everyone be very excited when I get back, because I promise it's worth being excited about. All right, who's excited? Let's see if the chat has displayed an appropriate level of enthusiasm. Is it a good idea to use a small aerospike nozzle on a solid rocket motor just for fun? Ian, really no. For solid rocket motors, there's solid particulates in the exhaust, if there's any aluminum in them, that actually destroys the efficiency of aerospike nozzles, because the solid particles can't make those turns. Do I have a Discord? No, I don't have a Discord. Can I make a series on rocket propulsion elements? I kind of think that's what the liquid rocket engine series is. Jamie, I guarantee that FAA clearance is not your biggest problem. Oh, it says it's not working. Can you guys hear me just fine? Suggestion, the audio stream bitrate is lower than the current lowest recommended bitrate. It seems like it's working. I don't know why I'm getting warnings. Okay. All right. What do I think of normally open valves for liquid-fueled rockets? Sometimes you need them. Just depends. Okay. Excitement intensifies. Oh. Okay, so this is a liquid pump I built after I saw someone post on Reddit a really, really bad pump design. And I'm like, I can do better. So this is a 3D printable pump that produces a pressure rise of 180 psi at an efficiency of about 50%. And it can pump not very much. It can pump about 10 grams a second at that pressure. Oh boy, this bolt is all corroded. But anyway, so yeah, this pump works. I've had it for like 3 or 4 weeks now. No, not that long, maybe 2 weeks now. It runs off of this 60 amp speed controller and just like a little PWM modulator and 6-cell LiPo battery. So you can't use it for like powering a rocket. The pressure isn't high enough, and it's also not appropriate for that application. It's just made out of plastic, but it demonstrates all the principles of how you make a pump for a rocket motor, and it's really cool. I'll do a video about it sometime. I just kind of did it mostly for giggles. There was no engineering or anything done as part of, well, there was a lot of engineering done as it, but like not very good engineering, just like mostly get it done and 3D printed engineering. Okay. So, what did we think of the pump? Was it cool? Exciting? People like to see it? Do people want to see a video on it? I'll make the video eventually. This is a problem that I have often, which is that I find it easier to make the things to make the videos about than I do to make the videos. All right. You might have to work with the Space Force and the Air Force. Yes, the Space Force and the Air Force are highly involved in spaceflight right now. Have I ever designed a space globe with a staged rocket as a payload? A practical solutions. Oh, you mean like a balloon? A raccoon? No. Raccoons are a bad idea. If someone tells you they're doing a raccoon, you should run the other way as quickly as possible because they clearly don't understand exactly how complicated orbital flight is. Okay. Do I have any plans to create a Discord for those of us that love you? Probably not. I don't have enough time to moderate a Discord, probably. And I kind of have to choose between, like, interacting on Discord and, like, doing all the other things I do, which is a lot of things. I know Starship and Falcon are different programs. Does SpaceX share wins or callouts for different ideas? Oh, I can't talk about SpaceX. Under NDA. I second those suggestions. Nope, sorry, no Discord. I hang out in the BPS space Discord sometimes if you're a patron of Joe Barnard, because then he has to do all the hard work instead of me. Discord is required to be a real YouTuber. Well, I'm clearly not a real YouTuber. I only have like 10,000 subscribers. If I get like 100,000 subscribers, then I'll make a Discord, because then I'll be a real YouTuber. When I get the like silver play button, that's when I'll make a Discord. Okay, let's see. You would like to see it in action. I wonder if I can set it up on stream. I probably am not set up to run it just, like, off the cuff, since my webcam is, like, literally taped to my computer. But I will make a video for it eventually. What was the pump pressure for your 70-pound thrust engine? NKMR, it was a 7-pound thrust engine. Not 77, like, 30 newtons, like, not much at all. And what was the pump pressure for it? I think the combustion pressure on it was 90 psi. It wasn't pump fed. Well, it was pump fed. It was actually pump fed by a diesel fuel pump and compressed oxygen gas. So it was really janky. At what point does something progress beyond amateur rocketry? Tusk, it progresses beyond amateur rocketry when you get paid for it. Colin, make as many videos as you want. We would be the last community to judge, and there's knowledge to be gained in almost any video you put out. You're right. However, unfortunately, every video I put out also takes time, so I have to pick and choose what I do. Do you reckon a 30-foot rocket with 4 smaller SRBs that separates into a third... Do you Jamie, I don't understand the question. But if you're asking if that can get to orbit, the answer entirely depends on your mass fraction. The size of the rocket doesn't matter. It's only the mass fraction. If you were telling me that, there was, it had a 90% structural mass fraction, then I'd be telling you no. If you told me it had a 96% structural mass fraction, I'd be telling you maybe. Okay. What do I think of the sick Minotaur launch? Yes, I love the Minotaur launch, where it just, like, zoomed off the pad. That was pretty cool. All right. Real Life Games has a point, which is that at this rate, we're never going to reach the Mun. And I do have other things to do tonight. I have to write some proposal stuff for work. So we're going to focus view on that. So this is the orbit I need to put the thing into. So I'm coming like this. So I need to burn up, I think. Let's add a maneuver. So if I go like that, that's what we want. And then we need to go prograde a little bit. So we come over the top. All right. and a little more. So what we're doing is we're messing with the orbit so that we come into the correct plane to deploy our little satellite. There we go. Nope, not quite. I think. So what we want to do is we want to line up our periapsis, and then we'll just burn just enough to get captured at periapsis, and then we'll go to apogee, we'll do our plane change maneuver, then we'll come back to periapsis, get into the correct orbit. So all we really need to do is we need to put this purple periapsis marker on that yellow periapsis marker is the only thing we're trying to do right now. So our inclination's a little high, and we're getting there a little early. So that'll fix our inclination there. And then that'll do that. And let's see if we adjust with the prograde retrograde. You know, we can live with that. We need a little more inclination. There we go. That's about as good as I think we're going to do. So let's set up and let's try and make this happen. Okay. Let's see. Patricio, if the rocket as payload could ignite when the balloon is almost near its max height, you could get to a rating. Patricio, altitude means almost nothing as far as going to space. The energy contained in your potential energy, your MGH energy of your rocket, compared to your orbital velocity kinetic energy is like 4%, maybe 2%. So having a balloon does not help you like at all. And the problem is that it makes the largest size of your upper stage fairly small because your balloon has to be able to lift it. And it turns out that you make your life harder with the smaller second stage than you make it easier by not having a first stage. It's just, it's not worth it. Balloons are not great. 46% structural mass fraction? No. 96% structural mass fraction. Your rocket needs to be 96% fuel, 4% structure if you're going to go to orbit. Azur, have I ever met Elon? Yes, I've met Elon several times. I've been in meetings with Elon. What should you be doing as a high schooler to try and steal your job in life? I mostly failed upwards. I read a lot of books. I had a lot of enthusiasm for what I do, but, in high school, I thought I was going to be a lawyer. So, passion and hard work can get you just about anywhere. Let's see. Matrix says, put the correction further out and I will save delta V. That is actually incorrect. The sooner you do your maneuver, the more delta V you save. The problem is that the small errors have time to add up. So if you aren't absolutely perfect, you'll have to do a plane change. Holy cow, that's a 400 meter a second. No, let's not do that. Let's try again. Yeah, there we go. That's what I want. Yeah, see, that one only has 7 or 8 meters a second. It's those inclination changes that really kill you. There we go. 40 meters a second. That'll do good enough. Save ourselves delta V by a factor of 10. Okay, I can already tell we're not going to have enough delta V to land this thing. But that's okay. We kind of suspected that back when we were in the VAB. Okay, would a degree in spaceflight operations be a waste of my time if you really want to have a hands-on job with a launch vehicle? Common Centaur, if you want to be hands-on with a launch vehicle, what you want is an A&P certification. That's an airframe and power plant certification as a technician. Or you could get a degree in mechanical engineering and try and become a launch engineer. At some companies, launch engineer is a very hands-on job. At other companies, launch engineer is a job back at headquarters. If you want to be hands-on, ULA and SpaceX highly recommended as companies to be a launch engineer at. Blue, the launch engineering there is maybe not as hands-on. Uh, Caleb, would you do more hands-on work with rockets as a technician or as an engineer? Universally, the answer is as a technician. Uh, Patricio wants to know, could I explain the reason why balloons do not work? So to go to orbit, you need to have a velocity of 8,000 meters a second. And if you take a balloon up to space and you drop the rocket off, let's say you could take the balloon all the way up to 400 kilometers where the ISS orbits. There are no balloons that let you do that, but let's just say you could. Then you would be dropped off at that altitude and you'd immediately start falling down, and you'd still have to get 8,000 meters a second of sideways velocity. So there's no... You don't gain anything with the blue. What you need is speed. I mean, yeah, it brings you up high. Yeah, it lets you use slightly more efficient rocket engines, but you've not solved your problem at all. Like, if you realize that, like, by the time the Falcon 9 is like 5 kilometers in the air, it's already as far down range as it is up. So you aren't... When you're launching a rocket, you're not launching a rocket up. It only looks like it's going up when it's close to the ground. When you're launching a rocket, it's mostly going sideways, and balloons go up, not sideways. Like, launching from an airplane is better than launching from a balloon. Even if you're hundreds of thousands of feet lower with the airplane than with the balloon, you actually get some speed from your airplane. And even then, it's not a lot. It's only a few hundred meters a second. It's really not worth it. Have I worked for Blue Origin? I have never gotten a paycheck from Blue Origin. I'll put it that way. Azur, what sort of college classes should I be taking to get a job designing rocket engines? Physics, mechanical engineering, thermodynamics, fluid mechanics. Those are all important. And know some programming. That's really helpful too. Lakshima, thank you for joining us. Common Centaur, how do you know, Charlie? ULA is my end goal company. ULA is a great company. They have a good work-life balance there. I had friends at ULA when I was at the Cape for SpaceX, and they always seemed more adjusted than me because they actually had lives. Ismail, Mechie versus Aero Astro Engineering. Whichever one you like better. You can do just fine with either. Really, it comes down to which set of coursework you prefer. Do I get paid a decent amount working at SpaceX? Jamie, that is a difficult to answer question. A lot of the pay you get working at SpaceX is not in money. It's in job satisfaction and benefits and other things that... Yeah, so if you're asking, will you make $1 million working at SpaceX, the answer is probably not. But you might enjoy your life. Tusk, did I watch the Virgin Galactic thing? Yes, I did watch the Virgin Galactic thing. Did I see the season 2 trailer for All Mankind? No, I don't watch TV, so I don't know. I haven't seen For All Mankind or anything like that, so I couldn't comment on it. Okay, so we need a little more delta V. 20,000. Okay. That'll work. Okay. What are good colleges for propulsion engineering? Caleb, the best college for propulsion engineering is Purdue. Michigan is a good one. Georgia Tech is a good one. Obviously, Caltech, Stanford, MIT. Yeah, I think those are the highlights of colleges. Grant Thornton, I am not accepting co-ops, unfortunately. Sorry. I would like to eventually, maybe, if the YouTube thing ever makes enough money for me to pay someone a living wage. I would not want to cheat anyone out of their hard-earned work. But you can always apply to the company I work for as a propulsion lead engineer, which is Agile Space Industries. Grant, I appreciate the offer, but I really can't do unpaid internships. It feels wrong to me to do that. Like, you would be creating value, and you should always be rewarded for creating value. Does SpaceX do internships? Yes, SpaceX does internships. So Patricio wants to know, so with the balloon, you wouldn't be able to escape the gravitational pull of the Earth because you don't have room to go fast enough because you're too high and would just fall down. No, not really. The balloon doesn't hurt you in any way other than forcing you to have a rocket small enough to fit on the balloon. What the balloon doesn't do is help you because it doesn't give you any velocity. So you were saying, like, if you take a balloon up and then fire a rocket sideways, yeah, you could still go to orbit, but it wouldn't be any easier than just launching from the ground. I mean, it would be like a little easier, like 4% easier, but it'd be then harder because you'd have to figure out how to make the balloon work. Gold Sparks. No, I don't work for NASA. I work for a company called Agile Space Industries, where I build rocket engines for satellites. Hey, Joey, welcome to the stream. Oh, hey, DemiPass. So Joey is a super cool dude. He is a grad student at a Joey, I'm not going to give your life story, but he's working on a satellite, and he's like a real aerospace engineer dude. So if he wants to tell that story, he's welcome to, but I guess I should probably ask permission before telling people secrets on the internet. All right. So Lakshima, balloons can only fly as high as long as there's an atmosphere that is denser than what is in the balloon. And you have to remember that the balloon is like the amalgamation of the density of both the helium in the balloon material, and then whatever you've hung under the balloon. Common Centaur. Joey B drops by sometimes, but I know for a fact he has better things to be doing this evening. He is trying to get a flight computer sent to the PCB fab shop, and it's an important flight computer that we should not distract him from working on. All right, so I've been doing a lot of talking and not a lot of flying, so let's get down to periapsis and get circularized around the moon. Guero, have a wonderful evening. Thank you for dropping by. Joey, you weren't here when I showed this earlier, but I think you'll appreciate this. I 3D printed a centripetal impeller pump. It has 180 psi pressure rise and a ADA hydraulic of like 50%. So that was kind of a fun project. If you want one for that MakerBot I hear you finally got working, I'll shoot you the STLs. You need a kind of ridiculous like pancake motor for the back of it though. It's a 700 watt motor. Ian, do you think if you did a few rocket projects, you would be able to get a job or an internship without going to college? Maybe. It depends on what the projects were and what company you were trying to get a job with. I know for a fact that one of the girls who I went to college with actually she dropped out of college, then she got a job at SpaceX, and then she decided she wanted a degree, so she went back to school at MIT. She was a very impressive individual. Okay, so we need to get to the periapsis and circularize. Goldsparks wants to know if a propulsion engineer and an aerospace engineer do fairly similar work. I would consider propulsion engineering a subspecialty of aerospace engineering. Maybe mechanical engineering, one or the other. But yeah, it's similar work. It's a similar skill set. Baraz, if you have a resume that you think makes you qualified for a propulsion engineering position at Agile Space Industries, please submit the resume. You can find a place to do so on our website. We are hiring. We are looking for a very particular set of skills right now, but for the right applicant, we certainly have positions open. Yeah, real life games, that's just nonsense if I understand what you're saying. Patricio wants to know, for deep space solutions, will nuclear-powered ion propulsion be more effective than SpaceX's Starship in terms of cost for translunar payload capacity? For translunar, almost certainly not. The moon is so close that ion engines are not suitable. But for Mars and beyond, maybe. It depends. One day. It depends on how much it costs to set the nuclear reactor up in space. Alright, so now we need to do our braking burn. Let's get flipped around and stomp on the brakes. Okay, so now we've got our orbit all the way out here, so we need to come out here and do our plane change and then our periapsis adjust. So we need to add our maneuver, and we need to be coming around the top. So if we're coming around the top, so if we're coming like this, and we need to go over the top like this, we need to turn our orbit like all the degrees. This was kind of dumb. This was maybe not great. $190 meters a second. You know, maybe we do have enough delta V to land on the Mun. So 700 gets us to 2,000. We can maybe do it. We'll try. You know what? I haven't given up on the Mun landing yet. We'll see if I have to eat my words in a bit, but we're going to try. So let's see. We've got 2 hours till our maneuver node to drop off our satellite. We will quick save real fast just in case I do a dumb while I'm paying attention to the chat instead of paying attention to my rocket. 30 minutes, 20 minutes, 3. Okay. Coming up on main engine shutdown. Shutdown. Okay, so just for the record, Kerbal Space Program handles these large inclination changes very poorly because it uses a static reference for the normal and anti-normal points. So if I wanted to do that burn more efficiently, I could have manually tracked those purple triangles and gotten, like, I think you could save about 33% of your propellant, but to be honest, I don't care. Okay, so we got that pretty well done, actually. Let's see. Let's check the errors. 2-degree error there. And then we'll come down to periapsis, and we will adjust our other parameters. So let's line up the nodes and wait till we get to the node. So we'll do our burn at the ascending node. And at the ascending node, we're going to have we need to burn, I guess that's going to be slightly east. So that's going to be this node right here. This, I think this is normal. So we'll burn normal just a little bit, and we'll check and make sure this is right. Yeah, there we go. 1, 0. Okay, so that fixed our inclination issue. Now we need to fix our apoapsis and our periapsis. So we need to go retrograde next. Okay, let's see. How are we doing on the chat? Sorry, I was actually flying the rocket for a little bit. Is this my first job out of college? No, I did consulting for a little bit for a couple of companies, actually one of which was Agile, starting in June of 2019, and then I started working for Agile on a part-time basis in July of 2019, and then I started full-time in January. Joey, actually a fission reactor has already flown in space. The Soviets flew several, and the United States actually flew a SNAP reactor once. Common Centaur, Charlie. My high school requires a senior year internship, which I am coming up on. Any type of place you think I should try and do it at to gain a useful set of skills for the launch industry? If you can find a machine shop, that's very useful, or a drafting studio, or an engineering firm. Those would all be great places. Okay, so here we've got our lander that may still be able to land. I think we can land. We may actually have enough delta V to pull this off. But so what we're trying to do now is we're trying to deploy this satellite in this orbit here. So what we need to do is we need to adjust our orbit so that our apoapsis is here and our periapsis is here. We've already fixed the inclination. So what we need to do is we're falling, so we need to lower our periapsis and get there sooner. So our apoapsis needs to be here. So if our apoapsis is here, that means we need to be falling faster. So we need to burn radial in to adjust this. I'm sorry, folks. I'm doing orbital mechanics in my head, and I'm totally winging it. So if we burn radial in, we will move our apoapsis back, I think. Okay, so that did that. So now we need to move our periapsis that way, we need to burn 90 degrees in between. So we need to burn prograde, but like not just prograde, we need to burn like there. You know what? We're just going to do this the old-fashioned way. if we come down to here and then burn retrograde, our apoapsis will end up there, and that'll fix it. But we need to burn up a little too. I said up. More up. More up, please. Mostly up. There we go. Okay, so that's pulling our periapsis towards us. That's where we want it. Okay, so now we need to burn retrograde to bring the apoapsis down. And the ascending and descending node is still okay. So we just need to bring the apoapsis down enough. There we go. All right, so let's go ahead and check our parameters. So new uncrewed space probe that has an antenna and can generate power. Reach the designated polar orbit around the Mun with minimal deviation. Okay, so I think all we have to do now is deploy the spacecraft. So let's try quick saving. Thank you for joining us, Real Life and Games. Which rocket do I like best? Redstone, Atlas, or Titan? Ooh, that's a good question. I think probably Titan. I like Titan. Titan's a very cool rocket. I don't have like a good engineering reason for that. I just like Titan. Okay, so now we need to get this spacecraft deployed. So cross our fingers. This is going to be energetic because I don't think I turned the power down on this decoupler. Hey, that mostly seemed to work. We need to deploy the antenna. And I think we can rename this. A2R sat thing. Accept. Okay. Reach the designated polar orbit around the Mun. Okay, so I've got thrusters on this, so we can make very tiny course corrections. So I don't know how minimal the deviations need to be. That's pretty minimal. I guess we're gonna have to make it more minimal. So we need it to be 785, and we're at 787. That was too much. Okay, so now we need to come out to the descending node. And probably do a little puff there. Not that. Hello, please show me. Get out of that. Go away. Go away, please. I don't want orbital info. Oh, is it not going to let me because I don't have a CurbNet connection? Okay. I see. So we're here. Which way are we going? We're going above the plane. So we need to go west. Oh, come on. That's west. Okay, that's less deviation. How little deviation does it want? This is like no deviation. All right, well, we'll fix the periapsis next. We're how high on the periapsis? We're 11 kilometers high on periapsis. So that may be something that actually needs fixed. So we'll now go retrograde. Retrograde, I said. All right, so now we're going to do a small retrograde burn to lower our periapsis by 10 kilometers. Hey, we did it. All right, that was it. That was what we needed to do, folks. Check it out. Okay, observe mystery goo. And we will transmit that data. Review data. All right, let's try transmitting. Warning, not enough electrical charge. Is there a way to just like set up so that it's going to try and transmit anyway? I don't think there is actually, now that I say that. I know there used to be, but I don't remember how to flip that toggle. So let's go back to the main spacecraft and figure how to land this sucker. Switch to. Okay, let's see. This rocket has amazing characteristics. You're right, Joey. It has one of my proprietary new propellant management devices that I invented on it. Okay, how do you ignite a SRB with hypergolic fuels? Jamie, you don't. You use a pyrotechnic train. Do I ever watch the old 60s hypergolic training films? Yes, I do. Can I do a video on decouplers? I guess I could, Jamie. In real life, they're pretty different, specialized, and proprietary, and so I couldn't talk about any of the ones that I have experience with at SpaceX. So it might be kind of different. Let's see. Are green hypergolics the safest, or is diethylene triamine dangerous? Green monopropellants, of which there are many flavors and varieties, come in differing levels of danger. Ionic liquids are pretty safe, though. You can usually handle those just in shirt sleeves. Joey, I would also like mods to make real life closer to Kerbal Space Program. Azur, the only way to get certified for ITAR is either to have a company sponsor you for a ITAR license, which is very hard to get and has to be approved by Congress, or you have to become a U.S. person, which means getting either a green card or U.S. citizenship. Sorry, there's not a lot of shortcuts around that. Patricio, have I heard about field propulsion systems? Yes, I think they're what we would call like Mach effect thrusters, and I think they're nuts. Kemphic, welcome to the stream. Joey is reminding me of a very specific failure during one of our rockets that we worked on together, where its aluminum is no longer sufficient justification that a part is strong enough. Okay. So we need to do a retro burn to get our periapsis down. We've got 2,500 meters a second of propellant. That's just barely enough to do this. So we're going to be very efficient. Okay. 58. We need 20. Maybe like 11. Like I said, we're being very efficient. So the most efficient way to do a MUN landing is to get your periapsis like as low to the surface as you can, and then slam on the brakes, and then rotate your ship 90 degrees, and then land. That's the most efficient way to do it. That doesn't mean that it's an easy way to do it. It just means that it's the theoretical best way. Oh, that's plenty high. We can go much lower than that. 6. That's cutting it a little close. All right. I think that's about as devilish as I'm going to be. Because the MUN's going to rotate, and I don't know if a mountain's going to come under me. Common Centaur. He did not have Mountain Dew present during the panel. But I also didn't have Dr. Pepper present during the panel. So was it really a panel between the two of us? Who knows? Patricio, you mean like Alcubierre drives? They are impractical because right now we don't have knowledge of any materials that can manipulate space-time in that way without being infinitely long or have negative energy. Since we don't know how to do either of those things, the math checks out and says it's possible, but they're engineeringly impractical. Okay. As a U.S. citizen, how do you learn about all of the insides of ITAR? No, once you're a U.S. citizen, you're ITAR exempt. You can do whatever you want. You don't have to be licensed or specialized or anything. Nope, no company sponsorship required. All right, so here we go. We're falling. We're getting ready to slam on the brakes. Joey, that's actually, I mean, an optimal launch is to go sideways right away, but you can't do that because you'd have to have an infinite thrust to weight ratio to not hit the ground. Um, so actually, it's not go up then go sideways. It's just start going sideways, and the less up you have to do, the more efficient you are. Um, you were in 512, right? We didn't do the launch optimization P set the year we did 512. Because I did the 512 P set with launch optimization the year I did it with the older people that Miller wouldn't let me be in 512. Anyway, reminiscing about classwork I did. Well, Joey, if the question Azar was actually asking is how do you make sure you don't accidentally export controlled information, it's by reading a lot, and usually the way people do it is just by not saying anything at all. And the way I do it is by reading a lot and living dangerously. Azar, there is not a lot of ways to do it better than just sitting down and reading the actual laws and bringing a law dictionary with you. It is not the most fun I have ever had doing anything in my life. Eve, Moho, Sun, Artemis 2. Okay. That's a minute 28 away. Gear down. We have sufficient quantities of electric charge to pull this stunt off. Oh, we are just down here in the weeds. All right, everybody, get ready for this. That mountain's getting pretty big. All right, we're going to start braking. Yeah, Joey, you're right. Go up not enough not to slam into the side of a mountain, and I think I may have forgotten that critical step during this landing. The horizon is getting mighty big in the window. Patricio, the solution for that is not just a nuclear reaction in reverse. I am not a super exotic particle physics guy. There's a lot I don't know, but I know enough to say it's not that. Charlie, have I ever come extremely close or even said anything in stream or in a video that is restricted by your job? Yes. Yes, I have. And then I either edit it out or don't say it or, trail off awkwardly and stop talking. I don't think I've ever said anything that can actually get me in trouble on stream, but I've definitely, stopped talking when I've, gotten into dangerous territory. And that's why I just don't allow anything about, Spacex on my streams, is because that's a very restrictive NDA that I have, and I also know that they are totally willing to interpret it as strictly as they want to, so there's just not a lot of leeway on that. 40, 30, 20. Seven, 20 down by 7. Oh, that's bad. That was the engine. Oof. Okay, I'm going to go ahead and say that those landing legs were not long enough. There's not any more Dr. Pepper in this. That makes me sad. Jamie, probably the thing that would happen if I broke the NDA is I would just never get a job there again. If I really, really, really broke the NDA, they could sue me into oblivion. So definitely don't want to do that. Yeah, I think F is appropriate. So we're just gonna pull the old F9 didgeridoo. As are people that have to deal with ITAR on a regular basis that And the ones that do get paid for dealing with ITAR, so they don't want to make your life that much easier. Do rockets thrust vector depending on the air pressure to create an aerospike effect? No, that doesn't really work. I mean, you can do that, but by the time you're doing that, the percent gain efficiency gain is like very, very, very small, so not really. All right, trying this again. Oh, we are dropping streams, guys. We are dropping frames. Looks like it's recovered. Dropped 1,000 frames. All right, we're still going down. We're still going down. Azure, no, college absolutely does not teach you anything about ITAR, which is frustrating, but college teaches you how to build rockets, and then you have to worry about the details of how you build them legally and effectively later. Oh, this is way too close to the ground. Okay. I mean, it's not. We haven't hit the ground. That would be too close to the ground, but, like, that was a little close for comfort. And now we're going up again. I don't want to be going up. I want to be staying close to the ground. We're going to switch that. I got a little high there. I wanted to stay, like, close to the ground. All right. 400 down by 80. 300 down by 30. Uh, 150 down by 20. 100 down by 20. 50 down by 8. 40 down by 3. 20 down by 5. Oh boy. Nope, 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 don't do that. No, 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 no. Darn it. All right, well, the engine didn't break this time, so at least we're okay. But that was not very... Maybe not the most fun I've ever had. That's okay. We're okay. Situation nominal. We're all okay. We can deal with this. Let's get Bob out on EVA here. Have him do some science type stuff. Plant a flag. July 28th. And we are on some glitchy terrain here, boys. Just crashing. July 28, 2020. Curbs be here. So let's grab a surface sample, take an EVA report, keep both of those, and reboard the spacecraft. We'll need a crew report. That's not useful. Okay. Now we need to figure out how to get this thing back in the air. Azure, no, ITAR really just says what you can and can't say about how you build something. So, you know, if you're a U.S. person, you're allowed to know everything you need to know to build a rocket engine, and you're allowed to tell any other U.S. citizen how to build a rocket engine. So ITAR just isn't a worry. The only thing ITAR controls is what you're allowed to tell not U.S. citizens about how to build a rocket engine. Common Centaur, I am personally most looking forward to the CLIPS part of the Artemis program. I think SLS has some programmatic issues they need to work on, I think is my delicate way of putting it. All right, so let's get this thing back up in the air. And I think the way to do this is just to, like, point it up this hill. Turn the RCS on. light the engine. Nope, that didn't work. Okay, trying again. Patricio, we don't even know what theoretical characteristics you would need to manipulate space-time. You would need to either be able to replicate an infinite mass, manipulate negative energy, or have an infinitely long spinning cylinder. Or you would need to do something that would trick the universe into thinking you had one of those three things. I think probably the easiest of those to work with is negative energy, but we don't even know what that is. We haven't discovered it. We just have, like, things where if you put a negative sign in the equation, interesting stuff happens. But, like, that's like saying you're going a negative speed. It doesn't exist. You can go in a negative direction with some positive speed, but we don't know how to go a negative speed. Patricio, do I think NASA will abandon the SLS project and just use Starship? No, there's 100% chance that does not happen. For whether that's a good idea or a bad idea, I don't know, but I do know there's 100% chance that it doesn't happen. Okay, well, we didn't kill the Kerbals this time, but they're no less... they're no better off. Well, let's try again. Jamie, Starship is pretty cool, but it is not the best rocket for everything. I mean, it's a really big rocket, so if you're trying to do, like, high C3 missions, you know, you're going to lose efficiency from having such a heavy rocket. Oh, I meant to call someone for their birthday today, but I forgot. That's not very nice of me, apparently. Okay. Let's get this thing into the air. What if I just do this landing leg? Okay, that is worse. That is not helping. We're going to rock, and then we're going to go up. Well, that almost worked. We were close. We're going to keep trying. Common Centaur, that is known as the sunk cost fallacy and is not a reason to keep doing something. A reason to keep doing something is, however, because it keeps senators happy that fund all of the other things you want to do. All right, so we've got this. That is not better. There we go. We got it. Woo! All right. Let's figure out what orbit we're launching into. We need to go east, so we need to flip around 180 degrees. There we go. Okay, so we're trying to rendezvous with this spacecraft right here. And this will fulfill the last thing we have on our contract here. Rendezvous 2 vessels in the orbit of the Mun. So we will keep going up. We're going to go to like 30 kilometers maybe? Node, 18 degrees. So we've got like some things to worry about. Okay. Whew! All right, that was an exciting launch, folks. But I think we got it. So we are almost done with this mission. we have been doing this for quite some time now, but we'll get this rendezvous done, and we will head back to Kerbal and declare success. Patricio, no, you don't need to take all the ideas seriously. That is how you spend a lot of time chasing down leads that go nowhere. What you have to do is you have to use what your knowledge of the physical laws of the universe are to find the most promising ideas, and then you have to spend a lot of resources delving into those ideas to characterize them. It's really tempting to just try anything that comes to mind, but remember that when you're testing these ideas, you need like multi-billion-dollar particle accelerators and, you know, hundreds of people working on them for years at a time. So if you just try anything, you know, maybe you get lucky, but probably you waste a lot of people's time and a lot of money. So you have to very carefully pare down your ideas to figure out what can be successful. Common Centaur. I actually have used historical mods for launch vehicles before. I actually made, back when I was first starting to play Kerbal Space Program, I modded Kerbal Space Program, and I made the ULA parts pack mod, and a Copenhagen suborbital parts mod, and I also made a submarine parts mod. And I worked on the Bobcat rover mod team, so if you ever go like way, way back in the forums, I think the forums have moved a couple of times since then, but you can find a bunch of my old posts with my old mods. The submarine parts pack mod was fun. That was back with the old water physics, back when like the oceans were made of lead and didn't have good density calculation code. So that was inconvenient to work with. I think it's gotten a little better since then, but back when I first started modding the game, there were a lot of things that were not very good. But it got better. Ooh, let's see. I'm headed to 44, 10, 11, 12, 16, 20, 28, 30. $45, 44. There we go. Okay. So now we need to get to the node. And the node is going to be here. And we need to burn kind of southy. Okay. Back to the chat. What languages do I code in? I know a lot of Python. I know a little C++. I know a little C#. I know some processing. I know a little HTML. A little JavaScript. I mostly do Python. Everything else is just something that I picked up along the way to do a specific project or something. All right, so we're coming up on the ascending node here, and we're going to burn south. Joey, I actually can't code in MATLAB. Like, I know my degree says that I can probably code in MATLAB, but, like, I rewrote all the unified p-sets in Python for a reason, and it wasn't because I just strongly disliked MATLAB. It was because I actually did not know MATLAB, and I did not want to learn. 15, 14, 13, 12, 11, 10, 9, 8, 7. We'll just wait till it flips around. There we go. 0.7 degrees inclination. All right, so we need to save like 500 meters a second to get back. So we're probably pretty good. We are doing okay. So here we need to burn in and prograde, in and prograde. Maybe out a little, prograde, out a little, and then prograde. All right, 62 meters a second, and then we just have to time warp so that the spacecraft phase correctly. We are almost here. Just line up on that ball there. 3 minutes. 30 seconds. 10 seconds to ignition. Shut down. How much propel? Oh, I've got plenty of monopropellant. Just kill these last few meters a second of velocity. Okay, we'll call that good. So now we just have to phase. So we are in a lower orbit, which means we are catching up to it, which is correct. We're only about 90 degrees behind it, so we'll catch up in just a few orbits here. However, used an electric pump on a liquid rocket engine? No, I've never even used a pump on a rocket engine that I built myself. Pumps are very challenging to use in rocket engines if you're trying to do it right. There's a lot of very tight tolerances to hold. You need a lot of equipment to do the balancing and whatnot. So I definitely don't feel like a pump is the best option for any of the rocket engines I've worked on. Night Common Centaur. Let's see. Can C# be used for Arduino? Not really. You need to use C++, but C# and C++ are not all that different, so you can be okay with it. All right, let's see. We are slowly catching up. All right, that's our second encounter. So that's the first one. So then when we get to the second one again, we'll be even closer. So that is the target position will be behind us. So we need to do an orbit raise. (20, 19, 18, 15, 12, 10, 7, 4, 3, 2, 2, 1.6. All right, that'll be good enough. Patricio, do I build the rocket motors for my rockets? Sometimes I do. I've built some really big rocket motors, but sometimes it's easier and cheaper just to buy them. It just depends on if what I'm trying to do has a rocket that I can buy. I really only build them if I can't buy the rocket motor I need. Good luck, Jamie, on your rocket launch. Hopefully it goes well. 3 kilometers is a pretty high flight. Hopefully it comes back close to the pad and you can find it. Gold Sparks, I've found everything that can be done in the world can be done in Python. You can write video games in it. You can use it for simulations. You can use it to steer rockets. I have found Python to be incredibly useful. All right, here we go. We're going to kill our relative velocity, and then we're going to begin approaching. All we have to do is get within visual range of them. So that won't take very long. Okay, so we've done that. Now we need to point at our target. (1.2) flip around. 650 meters a second. We are cutting it a little close with the delta V to get home. But I really don't want to fly another MUN mission after doing 3 MUN mission streams in a row. That just starts to get boring. So that's there. So if we go this way and burn like here, yeah, that's what we want. Okay. So we're burning to lower, oh, come on, I fumble fingered that. So we're burning to lower our orbit so we slow down, sorry, to raise our orbit so we slow down so that this other spacecraft catches up to us. But then I just pushed the wrong button, so now we're just kind of pointing towards it and burning. But that's okay. We can make this work. So now we want to burn straight away so we keep our relative velocity vector in the right spot. I keep hitting the Z key when I mean to hit the X key. But on the bright side, at least we're still going towards them. 300, 200. We'll get pretty close. I don't know if it'll count enough to close out the contract. We may have to fly a little closer, but we'll at least be like within spitting distance. Three, 2, 1.5. There we go. Okay. So we've got 7 units of monopropellant. Let's see. Okay. Patricio, have I ever built a full cycle engine? No, I haven't. In fact, the number of groups that have ever built a full cycle rocket engine are like basically like 2. So no, I haven't. When will my next stream be? Who knows? Probably like some number of weeks from now. Patricio, have I ever tried an aerospike? Yes, I have tried an aerospike. I am one of the very few people you can talk to who has actually tried a fired aerospike. They're garbage. Don't do them. They're horrible. Let's see here. Joey, at the risk of being politically correct on stream, the current NASA style guide suggests the use of the word crude when talking about the crewed space program. Same number of letters even, so. And, you know, it adds an extra 50% of the population, which the politicians like. I think we can break here and call it inside of visual range. Is that going to be good enough for the contract? Yes, it will. All right, now all we have to do is go home. Let's plan our trip home. Let's plan our trip home. Add a maneuver. We need to unset target. Let's see. A little more delta V. And a little bit better use of that delta V. A little bit better use of that delta V. I'm sorry, I said a little more delta V. Let's see, that's 390 kilometers. $218. There we go. That's it. That's what we need. Let's point this sucker at the maneuver node and get headed home. There we go. That'll do. That will do. 28 minutes till the burn. Troglin, can we light a liquid rocket engine with only an electric arc? Or Tristan, yes. Yes, you can, Tristan. This is, typically you have like a little gas chain to do it with too, so it's called an augmented spark igniter. But you have to, do whatever's right for your application. Patricio, I have built, I have seen a static-fired ethanol nitrous rocket aerospike. It had an oxygen hydrogen preburner, and it was a total mess. Gold Sparks. Hey Charlie, what do I think of von Braun's rotational space station concept? I don't know. entirely ambivalent about it. 10 minutes. Sequence start. 12 seconds. Here we go. Well, just knocked my earbuds out. And light this sucker. Stand by for shutdown. Mark. That puts our periapsis at 18 kilometers, which is like a little low. But we can fix that in a second. Going in a little low, so we want to burn easterly, I think, to raise our periapsis just a little bit so that we don't come screaming in quite so hot. Although I think we have plenty of heat shield. There's no reason. Hit the brakes. Magnetometer dating? Magnometer meeting. Nope, don't need that either. All right, then that means it is time to blow this puppy. There we go. And now all we have to do is survive reentry. So we're going to do this by flying a lifting body entry, just to make it a little less stressful on the craft. So you can see that by angling the capsule like this, the wind is hitting us this way and being deflected downwards, generating a very small lift vector that way, which increases our angle of flight and slows down our deceleration period. We're just kind of waiting to bleed off enough speed so that we can land this thing. 2,600 meters a second. We are all the way up here, screaming fast. Ian, dare you say it, but if you don't know how to light a liquid rocket engine, you're not fit to build one. Yeah, there's hazards associated with not knowing how to do something. I designed several rocket engines just on paper before I ever started building one, so that's sometimes a thing to do. Guys, I'm not a big... One of the things you have to do in order to have time to do as much cool stuff as I have the opportunity to do is you have to pick things you don't do. So I don't watch a lot of TV. Twitter is my bad habit, social media. I don't really do other social media. So it's a thing. You gotta pick what you want. So we've got plenty of ablator here, so we'll be just fine. Let's see, which one of these is the Drogue Parachute? Oh, they aren't even overheating. This is fine. That's the Drogue Parachute. We can use that when we slow down a bit more. Jamie, I should probably advise you to make somewhat better life choices. I promise I'm not as interesting as sleep. All right, 1,300 meters a second. I think we can time warp the rest of our way down. Surprisingly, it looks like the service module survived fairly well. Usually I would have expected that to burn up, but I guess we came in pretty high. All right, we're getting ready to hit these clouds. We'll pop the Drogue Parachute here at like 5,000 meters. And jettison the heat shield. Sayonara. As it goes flying away. And that's the Drogue Parachute. And those are the main parachutes. All right. Safe touchdown on the surface of Kerbal. How about it, folks? Let's make sure we check this box off. I think that's 2 contracts done. Very successful. $120 science, 30 science. We got like 1,200 credits back. Nice. Very successful. Let's see if we can turn that science into any cool new parts. We could get aerodynamics, but who cares? Space exploration. This has the cacti telescope parts, so we could build a space telescope. That could be fun. This has photovoltaic array, the parts controller, lots of unfolding solar panels. That's kind of interesting. The actuators, I think, may be the best gig. This has wheels, rover parts. It has the rotational servos. It has winches from Kerbal attachments. It has this advanced grabbing unit. We could go visit a comet. That seems like a really great idea. We may do that. The other option is we could do this precision rocketry. Nuclear propulsion. That takes 300. And I don't really like nuclear propulsion that much. These are all 300, 300, 300. It may be actuators. I'm feeling actuators. Let's see. This has nose cones, some Werner engines. Precision engineering has what? This has more antennas. This may be something we want. Ooh, this has lots of options. What is this? Advanced electrics. I don't know. I kind of think actuators has it, so we're going to go ahead and research actuators. Sorry, folks. Space Telescope lost. The Space Telescope's just not a particularly interesting mission to build and fly for you guys. If we get a contract to do it, we might, but we have some good contract options. We may do this orbital space station. That sounds interesting, but we'll figure it out as we go. So thank you all for tuning into the stream, and I think that does it for tonight. So have a wonderful evening. Bye-bye, all.